So this is my molecule, silicone tetrahydride. It is SiH4. A fun fact about this also is it's kind of deadly, so don't breathe it in, and at room temperature it's also a colorless gas, so you probably won't be able to see it anyway. The green is going to be the silicone, bonded by nonpolar covalent bonds to our 4 hydrogens, which are in purple. The main compound is just nonpolar. You can see the many lines of symmetry in that. The IMF is going to be dispersion forces only. Our bond angles are 109.5 degrees, and our hybridization is sp3. Alright, so this right here is going to be a melting point for my molecule, and this -112 is going to be a boiling point for my molecule. Alright, so what is this? This is the temperature side, and you can look down here, and on the x-axis this is going to be heat increasing as you go further. So what does all that even mean to me? Like, why does that matter? Well, this first line right here, it's going to be a solid. Alright, so these guys are all in a mosh pit. If I was trying to go through, that would not happen, alright? So this is gonna be my example. You see how it's a nice solid. I put in the container. Look at that. It's still a solid. There's no way I'm gonna be able to change it. It's just like a giant mosh pit. As I was showing you guys, the solid, well, it's gonna have a melting and freezing time, which is this line right here, and that's whenever it hits its melting point, and it's gonna go to a liquid. The IMF right here, what does that even mean to us? Well, this is going to get stronger. It's gonna be 100% better as you're reaching liquid. Alright, so this is going to be our liquid form, which means our solid did hit its melting point. Alright, so now it's kind of spread apart. You can kind of make your way through it. You can also see that it's now filled the bottom of the container. This is a liquid. Now up here, from liquid, it's going to go to a gas, and this is going to be a boiling / condensing point. And that's whenever the liquid hits its boiling point, it's gonna go boil, 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 gas, and if you're going backwards, it would be condensing. And the IMF here, what is that? Well, it's gonna be the exact opposite as the IMF down here. This one's gonna get weaker and eventually break. Alright, so this is gonna be the gas. They're very spread apart because it hit its boiling point. Now, as you can see in this container, there's nothing there because gases can go wherever they want. There is no longer any kind of mosh pit, no longer any kind of regulation for them to follow. This is my molecule, silicone tetrahydride. Woo!